Hello, am I audible? Hello, am I audible? So our discussion topic is linear programming problem from PYQ question paper. So let's start the discussion. So our first question here. This is the first question. Okay. So first question say that consider consider the following linear programming problem. Max z equals to minus 3x1 plus 2x2 subject to x1 less equals to 3, x1 minus x2 less equals to 0, x1 minus x2 greater equals to 0. Okay. So which statement is true? First statement say that the primal polynomial has an optimal solution. The primal problem has an unbounded solution. The dual problem has an unbounded solution. The dual problem has no solution. Okay. So question is visible. Question is visible. Everyone say that question is visible. So this type of problem we can solve by graphical method. So first we this inequality convert to equality. So here first subject to condition say that x1 less equals to 3, x1 minus x2 less equals to 0, x1 minus x2 greater equals to 0. Okay. So this inequality we can convert x1 equals to 3, x1 minus x2 equals to 0, and also x1 minus x2 equals to 0. Okay, is it clear? So we draw the graph and we see that this is the x equals to 3 straight line, and here say that less equals to 3 type, that is toward origin. Follow. Here x1 minus x2, that is x1 equals to x2, that is straight line passing through origin. That means here x1 minus x2 less equals to 0, that means toward origin. Another say that x1 minus x2 greater equals to 0, that is throughout origin. Okay. First means x1 minus x2, that is less equals to, and second is greater equals to. Okay. So this graph clearly say that the primal problem has an unbounded solution, because here we see that x less equals to 3 and x1 minus x2 less equals to 0. This is bounded, but x1 minus x2 greater equals to 0, which is unbounded. So the problem has unbounded. So here the primal problem has optimal solution. First option is discussed. Okay. The primal problem has unbounded solution. This is okay. Okay. Now here say that dual problem. Here second question is 3 and we say that duality. So duality means given maximum problem. So dual say that this is minimized problem, and subject to condition less equals to type, which is convert to greater equals to type. This is the standard form. So we can write dual problem say that minimum of z, this right side. So here right side only 3 exists, that is 3v1. Okay. And subject to condition we say that first we here subject to condition all above less than type. So here uh, third subject to condition inconsistent, not less than type. So first we convert this is less than type, that is minus x1 plus x2 less equals to 0. Okay, that is standard form. Then we convert it duality. Okay, so here row written by column and column written by row. Okay, so we subject to condition we can write, that is x1 x1. So b1 plus b2 plus b3 greater equals to this value we can write, that is minus 3, and here x2 not exist, here x2 and x2 exist. So v minus v2 minus v3. And good evening, good evening. So minus v2 minus v3 greater equals to 2. So here we see that if we put here v1, v2, v3 greater equals to 0, if we put v1 is equals to 0 and v2 equals to 0 and v3 equals to 0, second condition does not follow. Second subject to condition does not satisfy, so the dual problem has no feasible solution. So here say that the dual problem is no feasible solution, so option D is correct. Okay. Other we can say that if the primal problem is unbounded solution, then the dual problem is no solution. If primal problem say that the no solution, dual problem say that this is unbounded solution. Easy to remember. Okay. So here option B and D is correct. I hope it is clear to everyone. Please comment any doubt. Is it clear to everyone? Is it clear? First question, is it clear to everyone? Okay. Now I am go to the second question. I think it is clear to everyone. So next question. This is the next question. So next question here say that consider the linear programming problem. Minimum of z is equals to minus twice x minus 5y. Okay. And subject to condition say that 3x plus 4y greater equals to 5 and x greater equals to 0 and y greater equals to 0. So which of the following statement following is correct? So first option says that set of all feasible solution is empty. Second option says that set of feasible solution is non-empty, but there is no optimal solution. Third option says that optimal value is attained at 0, 5 by 4, and option D says that optimal value is attained at 5 by 3, 0. Okay. Now go to the second question, and this question say that this is also based on graph theory. And maximum problem we solve this graph theory because graph theory is the easiest solution. So this question, consider the linear programming problem. Here minimum z exists and subject to condition this. So which option is correct? Here option is very important. First option say that set of feasible solution is empty. Second option, empty means null set. Okay. Does not any solution exist. Second option says that set of feasible solution is non-empty, but there is no optimal solution. That means only feasible solution exists, does not optimal solution. That means say that optimal value is attained 0, 5 by 4. Here say that, and option D says that optimal value attained 5, 3, 5 by 3, 0. Okay. So this problem we solve by graphical method. So we draw the graph, we set this type of graph. Okay. So this cut point we say that 5 by 3, 0, and this cut point say that 0, 5 by 4. And this is greater than type, so obviously outside of the line we draw. Okay. So here we shadow region, we see that this is our feasible region. Is it clear? Okay. So it is clear that is unbounded. So we see that set of feasible solution is non-empty, but there is no optimal solution. Here feasible solution exists. This is one solution, this is one solution. So feasible solution exists, but our optimal solution does not exist. Okay. This is also solution, this is also solution. We can write that. So feasible solution exists, but optimal solution does not exist. So here option B is correct. I hope it is clear to everyone. It is clear? Please comment. It is clear to everyone? This is the unbounded solution. Here optimal solution does not exist. Here only feasible solution exists. So feasible solution exists, that is solution non-empty. Empty means does not solution exist, but here solution exists. Here this is on one corner point, this is one corner point. If we put z is equal to at 0,5/4 one solution, we get one solution. If we put z equals to z at 5/3, 0, that is another solution. This solution is called feasible solution. But optimal solution does not exist because this solution is unbounded. This feasible region is unbounded. So optimal solution does not exist. Feasible solution exists. So this feasible solution exists. So the set of feasible solution is empty, but there is no optimal solution. So here option D is correct. I hope it is clear to everyone. Okay? Clear? Clear? Second question clear? Now go to third question. Third question says that this is based on Csir Net 2015 December question. This is also based on linear programming problem. So here consider the following linear programming problem. Maximum of x1 plus 5/2 of x2. Okay, here max did say that x1 plus 5/2 x2 and subject to condition 5x plus 3x2 less equals to 15, and another subject to condition say that minus x1 plus x2 less equals to 1. Third subject to condition say that 2x1 plus 5x2 less equals to 10 and x1 x2 greater equals to 0. So here options say that has no feasible solution, has infinite many optimal solution, has a unique optimal solution, has an unbounded solution. Okay. Everyone write this problem. This is also based on graph theory. We can solve. So this problem we solve. This inequality convert to equality. So first equation here 5x1 plus 3x2 is equals to 50. So this is, we can write x1 by 3 plus x2 by 5 is equals to 1. Okay. Second equation say that we can also write x1 by minus 1 plus x2 by 1 is equals to 1. So this is the straight line equation form. So cut point is, this equation cut point is 3, 5. This equation cut point is minus 1, 5. Minus 1, 1. So, and also number 3 we can say that x1 by 5 plus x2 by 2 is equals to 1. This is cut point is 5, 2. Is it clear? Is it clear to everyone? So now this 3 straight line graphical presentation, we see that this is the first straight line, this type, and this is the second straight line, this type. Here say that minus 1, 1 is the cut point, and 5, 2 another cut point of the straight line. So all straight line less equals to type, that is toward origin. So that is toward origin. We see that this is our bounded region. Okay, this is clear to everyone. So this region here corner point is this, and this. Okay, clear? So just I will find this corner point and put z, and which is the maximum value, and this is our optimal value. If there exists unique optimal, then we call unique optimal. If there are many optimal solutions, then it's called many optimal solution. Okay. So first we find this corner point. So here This is corner point is called 0, 0. That is origin. Here corner point, that is B. So B corner point is 3, 0. This is E. So E is first equation, that is 0, 1. And here D and C, this is the cut point. So if we find C, so solve with 1 and C equation, we get 3 cut points. If we D find cut point, D point, if we solve 1, 2 and 3 equation, we get cut point of D. So this is our value. So now we find Z at 0, 0, Z at 0, Z at 45 by 9, 20 by 19, Z at 5 by 7, 12 by 7, and that is E, Z at 0, 1. So this is our value. Here we see that at 15 by 9, 20 by 9, here is also given value 5, and 5 at 5 by 7, 12 by 7 also given value 5. So here these two optimal solution exist. So more than optimal solution exists. So here option B is correct. Has infinite many optimal values. Does not unique optimal values, which is bounded. Obviously we see that this is bounded. So option D is discussed. No feasible solution. Here we see that there exists feasible solution. This is also discussed. So here option D is correct. I hope it is clear to everyone. Any doubt, please comment. So here option D correct. Any doubt? Please comment. Is it clear to everyone? Is it clear? Is it clear? Now go to next question. I hope it's clear to everyone. This is question based on CSIR Net 2016 June. Okay. So it question say that maximum of 3z, maximum of z equals to 3x plus 4y subject to condition x greater equals to 0. Please tell me once again, madam, that region point. Okay. Okay. This is clear to everyone. First we solve this inequality, convert to equality. First we convert this inequality equation, convert to equality. Okay. So if a straight line x by a, y by b is equals to 1, then a and b passing through this straight line. Okay. So first we write this straight line this type. So here 3, 5 passing through this straight line. Second straight line passing through -1, 1, and third straight line 5, 2. So now we draw 3, 5 straight line, -1, 1, and 5, 2 straight line. So now we draw and this type of graph. Okay, and all subject to condition here say that less than type. So all towards origin. Okay. So here we see that this is our bounded region. Okay. So this is our bounded region. So obviously we see that this is our corner point. So our corner point say that this. Okay. Okay. That is region bounded. Okay. So this is origin. So this value is, this corner point say that 0, 0. This point is B. This is B. This is one equation. So here this is one equation. One equation say that this is B. So this is point is 3, 0. This is cut point of equation 1 and 2. So now we solve 1 and 3. We get this point, and we solve 2 and 3 equation. We get D point. Okay, and this is E is 0, 1. Okay, so find C and D. We get C equals to at point 45 by 19, 20 by 19, and if solved D with help of 2 and 3 equation, we get 5 by 7, 12 by 7. Now we put at each point maximum object, this equation, this value. So when at 0, 0, z equals to 0, when at z at 3, 0, z equals to 3, at this point 45 by 19, 20 by 19, we get this value z equals to 5. When at 5 by 7, 12 by 7, at z equals to 5, and 0, 1, we get z equals to 5 by 2. Okay, so this is our value at point. Okay, so here we see that 5 is 5, 5, 2 times exists. Okay, so here we see that 5 is 2 times exists. So optimal solution more than 2, more than 1. Okay, so here say that has unique optimal solution. Here we see that there is optimal solution is 2 times. So option C is discussed. Has unbounded solution, here say that. So this is bounded solution. So this is also incorrect. Has no feasible solution. Solution exists, but definitely it is feasible solution. So first option is also discussed. So here option second is correct. Has infinite many optimal solution. We obviously see that there is optimal 2 optimal solution. So here maximum value is 5, 5, and 5, 5 is 2 times exists. So here more than 1 time solution exists. So LPP has infinite many optimal solution. So here option B is correct. I hope it is clear. Clear? Is it clear? Now go to next question. Is it clear? Any doubts? Please comment. It is clear. Okay. Now go to next question. This question based on Csir Net 2016 June. So here question say that maximum of z equals to 3x plus 4y subject to condition x greater equals to 3, y greater equals to 0, x less equals to 3, and half x plus y less equals to 4, and x plus y less equals to 5. And which option is correct? Okay. So which option is correct? Here option say that the optimal value is 19, the optimal value is 18, 3, 2 is extreme point of the feasible region, and 3, 5 by 2 is an extreme point of the feasible region. Okay. Clear? Question is clear? Question is clear to everyone? Question is clear to everyone? Please comment. Question is clear? So this is also the graphical method we can solve. So first we convert inequality, convert to equality. Okay. So here inequality, first say that x less equals to 3, second half x plus y less equals to 4, and third is x plus y less equals to 2. Okay. So first we convert inequality, convert to equality. Okay. So this inequality convert to equality, we can see this type of graph. Okay. And all is less equals to sign. So all the points towards origin. So this is our bounded region. So bounded region exists, we see that. So now we find corner point. Okay. So here we obviously see that this is our corner point, 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 and this is our corner point. Is it clear to everyone? So this is our all about our corner point. So we know that this is corner point value is 0, 0. Okay. This corner point value is 3 comma 0. Okay, because this is passing through x less equals to 3, so definitely this is 3 comma 0. Okay, this corner point is 4 comma 0 comma 4. Okay, so here just find C and D, this corner point and this corner point, our finding. Okay, so here we see that this C point, this is cut point of this equation and this equation, that is 1 number equation and 3 number equation. So if we solve 1 and 3 equation, we get C point. Okay, and this is our D. So this is cut point of 1 and 2 equation. So if we solve, 2 and 3 equation. So if we solve 2 and 3 equation and find x and y, we get D value, point of D. So this is our task. So first we find C, solve 1 and 3, we get x equals to 3 and y equals to 2. Okay, so here C point is 3 comma 0. Now next find D, solve 2 comma 3, 2 and 3. So we get x equals to 2 and y equals to 3. So here C equals to 3 comma 2 and equals to 2 comma 3. So all corner point we find that. Now we solve at 0 0, what value of z, at 3 comma 0, what value of z, at 3 comma 2, what value of z, at 2 comma 3, what value of z, and 0 comma 4, what the value. So here obviously see that this is our maximum value, problem is maximization. So definitely we just find a maximum value, and this maximum value our optimal solution. So definitely this is our optimal solution. So here optimal value is 18. So which option is correct? So here optimal value is 18. It is correct. So here R. So also can also find also correct answer there exists. So here 3 comma 2 is an extreme point of the feasible solution. So here optimal value, it is 18. So which point? 2 comma 3. 2 comma 3. 2 comma 3, and here say that no. This is also incorrect. This is also incorrect. This is also incorrect. So here option B is correct. I hope it is clear to everyone. This is only option B is correct. This is called 2 comma 3, not 3 comma 2. Okay. Is it clear to everyone? Now go to next question. This question based on CSIR Net December 2016 question. Here question say that consider the linear programming problem, maximum of z equals to 3x plus 5y subject to x plus 5y less equals to 10, 2x plus 2y less equals to 5. Okay, and x greater equals to 0, y greater equals to 0. Then which option is correct? The LPP has not admin any feasible solution. There exists a unique optimal solution to the LPP. There exists unique optimal solution to the dual problem. The dual problem has unbounded solution. Okay, so which option is correct? This is also based on graph theory. We can easily solve it. So first we convert this inequality, convert to equality. So everyone try this inequality, convert to equality, and find their feasible region. Okay. So first we convert this inequality, convert to equality, and draw the graph and find your corner point and boundary region. Okay. Solve it. Everyone try and please comment. So this inequality convert to equality, we get here this cut point is 10 comma 2, here this cut point is 5 comma 5, and here cut point is 5 by 2 comma 5 by 2. Okay, so now draw the graph and we see that this type of graph, and all is toward origin. So this is our bounded region. Okay, is it clear? So this is our corner point, and this is our corner point, and this our corner point. This is our bounded region. Okay, is it clear to everyone? So we can find A. A means 0, 0. Here also B. Here B is 5 by 2, comma 0. You can easily see that. And here also see that D is 0, comma 2. Is it clear? Now C is the cut point of equation 1 and 3. So now we solve equation 1 and 3, and we get obviously the point of C. So we just solve C with help of equation 1 and 2. So equation 1 and 2 we get we get x equals to 5 by 8 and y equals to 15 by 8. So we get this is our C point value. Okay, is it clear to everyone? Now just put value. When at 0, 0 we get z equals to, at 0, 0 we get z equals to 0. At 5 by 2, comma 0, z equals to 15 by 2. At 5 by 8, comma 15 by 8, at z equals to 19 by 8. At 0, comma 2 we get z is equal to 10. Okay. So here we see that this maximum value is unique. So this solution is optimal. Obviously, this is our maximum value. So optimal value, maximum value is only one exists, that is unique solution exists. We can say that. So here first option says that the LPP does not attain any feasible solution. So here we see that the 4 feasible solution exists. So first option is discussed. Okay, feasible solution 4 exists. So first option is discussed. There exists a unique optimal solution. Obviously we see that there is a unique optimal solution, that is 19 by 80. One unique solution. This is correct. This is our correct statement. There exists unique optimal solution to the dual problem. Obviously, if the solution exists, primal problem, then also dual problem has also solution exists. So here primal problem has solution optimal exists. So there exists also dual problem solution exists. So C option also correct. Okay. C option is also correct. The dual problem has an unbounded solution. So problem is bounded, so does not unbounded solution. So this is obviously incorrect statement. So here option B in B and C is correct. Okay. Dipankar said that, Madam, can you please tell me about the difference between feasible and optimal solution? Okay. All solution is feasible solution. This solution, this solution, this solution. If we find at z equals to this point, solution exists, that is called solution is feasible. If the solution exists, then solution is feasible. Okay. If x and y exist, then the solution is feasible. Okay. Our optimal means unique. Optimal means that is problem is maximized. So here maximum value, which option is maximum? Which option is maximum? That is 19 by 8. So 19 by 8 is 1. So here optimal value or optimal solution is exists. Previous math say that this problem we see that here 8, 0, 9, 17, 18 all about feasible solution because solution exists. Okay, but optimal solution here, which option is maximum? Which one is maximum? That is 18. So 18 here optimal solution. Is it clear? Another option say that if we discuss this problem, here we say that 0, 5, 5 by 7 all about feasible solution because solution exists, that is feasible solution. Here maximum value 5 and 5, 2 times 5 of 5 exists. So here optimal value twice, one is 5 and another is 5. So here optimal solution not unique, here optimal solution more than 2 solutions. Okay, is it clear? Is it clear? Feasible solution means solution exists, and optimal solution, which option is, if the problem is maximized, then which is maximum value. If the solution is minimum, so which gives minimum. That is our optimality. It is clear to everyone? Okay, welcome. Now go to next question. This question, Csir Net 2017 June. Okay. Question say that consider the problem maximize of 2x1 plus 2y1 plus 3y2 plus 5y3 plus 4y4. Subject to condition say that y1 plus y2 less equals to 1, y2 plus y3 less equals to 1, y3 plus y4 less equals to 1. And y4 plus y1 less equals to 8, and each yi greater equals to 0. So optimal value find. So which option is correct? So first say that equal to 8, second say that between 8 and 9, third say that greater than or equals to 7 or less or equals to 7. Which option is correct? This is not we solve graphically method, because here more than 2 value exists. So graphical method we only solve here 2 value exists. So here more than 2 value exists. So this problem we cannot solve it graphically. So this problem we try simplex method or to be different type of method. Okay. This is not solved. We can solve this graphical method. Okay. This problem we can solve this simplex method, maybe two-phase method, all about method. Here I can say this problem solved by Hidden-Tal method. Okay. What is Hidden-Tal method? Hidden-Tal method means I am consider some point this and solve it. Okay. So this problem we solve by Hidden-Tal method. First we let here say that each yi greater equals to 0. Okay. I 1, 2, 3, 4. So here that means y1 greater equals to 0, y2 greater equals to 0, y3 greater equals to 0, and y4 greater equals to 0. All about we consider greater equals to 0. So we can also put equals to 0. So first we consider or first we let y4 equals to 0. So if we put y equals to 0, okay, if we put y equals to 0, so here say that y4 plus y1 less equals 1. So if we find y4 equals to 0, so obviously y1 equals to 0 or less than 0 type. Is it clear to everyone? Okay. So again, if we find y1 equals to 1, so first relation we see that y1 plus y2 less equals to 1. So obviously y2 is equals to 0. Is it clear to everyone? Okay. Again we see that if y1 equals to y2 equals to 0, so if we put this relation, we get y3 equals to 1. Is it clear to everyone? This is type of Hidden-Tal method. Okay. Just we consider this. Okay. So now we put maximum of z y1, y2, y3, y4. So which we get value? Max of z is equals to y1 equals to 1, that is 2, plus y3 equals to y2 equals to 0, y3 equals to 5, and eta also 0, that is 7. So maximum of z, if possible, should be 7. So here say that equals to 7. So first option is discard, because we can easily find that maximum of z equals to 7. Is it clear to everyone? So first option discard. Second option say that between 8 and 9. So here obviously see that this value maximum of z equals to 7, not between 8 and 9. So this is also discussed. Is it clear? Say that third number say that greater than or equals to 7. This should be correct because they are equals to condition. Say that here less than or equals to, it is equals to condition. So obviously option here C and D correct. So here option C and D correct. Okay. Hidden tile method means here this type of question. This is our question MCQ type question. So I will try this can solve minimum time consuming. So this problem is maximized problem, less equals to type problem. So definitely we can solve this graph simplex method. Okay. So simplex method, it is long method, it is time consuming method. So another method is called, if we try hidden tile method, this problem is we can easily solve it. What is hidden tile method? Hidden tile method means here say that I greater equals to 0. So possible we can possible value we can put, and what is the maximum value? What is the maximum of this possible? Is it clear? So here say that is yi greater equals to 0. So obviously but y1, y2, y3, y4 maybe 0, maybe 1, maybe half, maybe. So here say that is yi greater equals to 0. So I just left y4 equals to 0. Okay, it's your choice. You also say that y1 equals to 0. You also left y2 equals to 0. That is your choice. Okay. So y4 equals to 0. So here say that this condition we say that y4 plus y1 less equals to 0. So y4 plus y1 less equals to 1, say that. So first I will try, I will put or I will set y4 equals to 0. So obviously y1 less equals to 1 times. Is it clear? So less equals to 1 times, that is also 1 or less equals to 1. So we consider also y1 equals to 1. Is it clear? Now here first option say that first subject to condition say that y1 plus y2 less equals to 1. So y1 plus y2 less equals to 1 say that. So if we consider y1 equals to 1, so definitely y2 0, 0. Is it possible? Is it clear? If we find y2 equals to 0, so second subject to condition say that y2 plus y3 less equals to 1. So definitely y3 also less equals to 1. So we can say, we can also write y3 is equal to 1. That is for hidden tile method. So here we find that y1 equals to 1, y2 equals to 2, y3 equals to 1, y4 equals to 0. So just put this maximum condition. We said maximum of z equals to 7 possible. Hidden tile method, just try. This is also possible. Okay. So here we see that max of z is equal to 7 possible. Here optimal value is equals to 8. So I also see that maximum value is 7. Also we can find. So this is not correct option. Our second option say that between 8 and 9. So here obviously we see that 7 is also an optimal solution. This is also discussed. Greater than or equals to 7, here say that. So definitely we can find 7. So equals to condition say that. So option C should be correct. Or here less than or equals to 7, it is also correct. So here option C and D our correct option. I hope it is clear to everyone. Any doubt, please comment. It is clear? It is clear to everyone? Any doubt, please comment. It is clear? Okay. Very good. This is our last question. So thank you so much. मिलते हैं अगले क्लास पर. Okay. Thank you. Good night.